Hello, everyone, and thanks for joining us as we discuss digital transformation with industrial IoT edge gateways and ignition. My name is Oliver Wang, and I've worked here at Moxa for the past 15 years, watching both the industry and the company evolve from physical Ethernet technology to cloud and software-based communications. We've done a few webinars on IIoT and on the Ignition platform, and it's been very interesting to see how things have changed in just the past few years. I'm happy to have Robert Jackson, Strategic Business Manager at Moxa, here today to share the trends that have emerged in IIoT architectures and hardware requirements. Robert Jackson is a 25-year veteran in industrial communications technology and specializes in driving business growth through strategic partnerships. Thanks to his work on our global partnerships with companies like Microsoft, Amazon, Chevron, and Inductive Automation, Robert has a deep understanding of the challenges faced by industrial companies that are moving to industrial IoT. In the next 20 minutes, Robert will discuss the technologies that customers are using today in their industrial IoT architectures and applications, first going over the different theoretical frameworks in use, and then going over two real and successful large-scale system architectures. Finally, we'll look at what we've learned about the type of hardware needed at the edge to support these architectures. Go ahead and submit any questions that come up in the chat or Q&A area. We'll have about 10 minutes at the end to try to address as many of your questions as we can. So Robert, I remember when you first presented these three basic architectures a few years ago. Can you explain what it's showing and what has happened in the market since you first presented this?
Sure. Over the past few years with the transition from polling to modern published subscribed architectures, our customers are really embracing digital transformation because of the improved performance benefits that it brings. Within the broad area of industrial IoT, we're observing three types of architectures, and we've shown these in the past, but I want to reiterate them today because they still hold true. First, we see edge to cloud, where devices like industrial IoT edge gateways connect directly to devices and sensors in the field. And these devices and sensors then can share critical monitoring data with cloud-hosted services. These applications typically consist of smaller, heavily distributed assets like a remote well at an oil site, or a distributed set of wind turbines. The second common architecture we see is a distributed application as well. However, the assets are typically a little bit more complex. For example, perhaps a small plant that's installed alongside a factory to generate oxygen or gases for production purpose. This middle area, or edge to modern SCADA, is a distributed system, and it often consists of several pumps, motors, and PLCs, but it is contained in a single unit. Remote access to these type of systems can improve billing accuracy as one example. The final area that we're seeing is early interest in remotely accessing critical machine data from a factory. While we see interest across all three architectures, we have seen more customer deployments for edge to cloud and edge to modern SCADA, the first two. And so for this webinar and the case studies that you'll see, we're going to focus more on those first two. As part of these three common architectures, we're also seeing customers reevaluate their approach to data access and security. The traditional Purdue model, while still very relevant, does rely on segmenting the industrial control system and networks into hierarchical zones. These zones can create data silos. And let's be honest, the whole point of industrial IoT is to avoid data in silos. So with the rise of cloud technology and edge connectivity, there's really been a different model that's emerged, a more flexible architecture that's become well known as the IoT model. And that's the picture you see here on the right, the cloud and the edge coming together. You can actually find this reference material on Wikipedia, by the way. So it's really become well known as the IoT model. But if we make a comparison, in many ways, this is like the transformation that happened with PCs in the office. Although I'm aging myself a bit, I can remember a time when business information could only be accessed by going into the office and having physical access to the facilities and honestly the computers in some cases that house that data. Even critical information like finances were isolated in a specific parameter with extra layers of physical access control. While this was the best approach given technology at the time, the benefits of remote access were so significant that technology and security policies evolved. And here we are today, where all company data is stored on a common server, protected by network security policies rather than physical access, and employees use company-issued laptops on their own devices to connect over VPN. Now, I'm not here to say that the Purdue model is going to go away. I just would suggest that the IoT model is starting to emerge and offers a different approach to some of our traditional data silo challenges. And I think it behooves all of us, all vendors and all of our customers, to think about what the future is going to look like. And who knows, maybe in 20 years, you'll look back and remember this webinar was a time we said maybe there's a transition coming away from the Purdue model. So
all
with
right.
that, Oliver, would you like to do the first poll question for us?
Yes. We like to do these polls to get a feel for where everyone's at. And we're talking about the Purdue and IoT model. Where are you and your customers? I'm talking to those folks on that are attending here. In this transition from the Purdue model to the IoT model, are you staying with the Purdue model? Are you exploring the IoT model? Are you adopting the IoT model along with the Purdue model simultaneously, or are you adopting the IoT model and skipping the Purdue model? Care to take bets, Robert? Where do you think our audience today is going to land here? I don't think we're going to have a lot on option one, considering this is an IoT webinar, but the second, third, and fourth options are kind of curious. Any bets?
See. We'll see. The Purdue model is still very established, so it'll be interesting to see if our audience is looking forward, or if it, as most cases, we're still using the technologies that are common today.
All right, let's close out the poll. Let's take a look. I'm curious here. Exploring.
Wow, I'm honestly surprised, guys. That's a lot of positive feedback towards looking forward.
All right, so exploring is where we get the bulk of the responses here today. So let's go on and talk about the architectures. Robert, this section is where you're going to walk us through some real ignition-based IIoT architectures in the space of just the past few years. We've gone from theoretical to production at scale. Before we dive in, can you share some thoughts about some lessons learned?
Sure. We have definitely moved from early proof of concepts and learned through real projects. Today, we have a much better understanding of the key questions to ask when selecting your software and the corresponding hardware performance benchmarks. And today in this webinar, we'll actually be sharing some new benchmarks and recommendations for you. But first, let's take a look at this basic industrial IoT architecture to connect remote devices to modern SCADA, the middle section. This was developed by a close partner of both Moxa and Inductive Automation, a company named Industrial Networking Solutions, or commonly referred to as INS. They have used this architecture with variations of what's deployed at the edge and also across several different customer applications. INS primarily engages two types of customers. First, customers with their own IT capabilities, and here INS can really consult on the edge architecture. Or second, customers without their own in-house IT expertise. Here, INS can provide guidance on both the edge, but in addition, the cloud SCADA and the additional of the control center integration. And so what you see here is a full end-to-end capability from the edge to the cloud to the control center to add visualization. And INS has developed this robust architecture in order to help you deploy more seamlessly and more straightforward. Let's first, though, go a little bit deeper. So here at Moxa, we're focused on the edge. So let's dig in on the edge architecture and discuss some of the trade-offs as the edge requirements scale. It starts with an industrial IoT edge gateway that's enclosed in a ruggedized panel. This panel almost always includes a cellular or LTE router, a managed switch, and the gateway. Commonly, the initial entry point is an ARM-based industrial IoT edge gateway running Ignition Edge with Moxa, Debian, Linux. This device then connects to local PLCs or RTUs and also sends data to the cloud over cellular using MQTT.
Robert, this architecture that INS is using is great. because as you described, it's very flexible and very scalable, whether you are simply collecting data from PLCs or also need visualization or even heavy computing at the edge. I like this next architecture that you're about to show us because it's a more detailed look at a version of IoT that does require high performance computing at the edge.
Yes, so let's dig in now to a customer's application. And so this second architecture was developed by Streamline Innovations. As their needs outgrew the entry-level connectivity of ARM, it really expanded something that was a lot more sophisticated and powerful. So first, to take a step back and provide some context, Streamline Innovations is a technology company focused on water and gas treatment and process improvements in oil and gas. Hydrogen sulfide, which is a colorless gas, causes tremendous issues for human safety, regulatory, and of course, corrosion of the equipment. Streamline improved the process and created the world's most efficient hydrogen sulfide gas treatment solution. They call this solution the Valkyrie system, and it deploys new chemistries and advanced control systems to remove hydrogen sulfide from natural gas. So Streamline faced many challenges, and they chose to use a modern IoT approach to address these and create a unique solution. Some of the challenges included the need to remove the requirement for an on-site experts to be present to adjust the control parameters. But they also needed a control platform that was advanced enough to do advanced calculations and incorporate weather data for model-based controls. The end result was an IT-OT converged solution. First, they used edge intelligence to perform the complex calculations, including the weather forecasts, to determine the optimal operating temperatures for the plant. Second, they used modern publish subscribe architecture of MQTT and ignition. A key piece here is MQTT allows cellular transfers of relevant data without consuming as much bandwidth. This quote from Peter Photos says it well. You can see that the advanced approach to adjust the surfactant and pH levels by adjusting the temperature with predicted weather information. Key point here, predicting what the weather would be and adjusting the temperature ahead of time, created a unique approach that allowed them to address their challenges of removing the local operators who had the advanced control capability and deploy a modern solution that could be managed from the cloud. Here is an overall system architecture of what they put together. And so first, on the top left, you can see this Valkyrie gas plant main skid. It's here on the right is a dedicated as a unit for removal of hydrogen sulfide from oil and gas wells. The core connectivity for the plant is based on a Moxa Industrial IoT Edge Gateway here in the middle. And this enables connectivity and the advanced control we talked about. The Edge Gateway can also connect to other plants within the network. And then they've added local HMIs and management systems for operators. A key component to enable the weather forecast data is connectivity to Azure. And so here Azure provides the advanced scripting and access to that global weather data. In addition, of course, it provides enterprise integration. But then in addition, within Azure, an Ignition server is also running. And this provides additional visualization and dashboarding tools in the cloud. And so as you can see here, it went beyond a simple application. They're doing advanced control, they're predicting the weather. They also have a lot of visualization, both local visualization for the operator and visualization in the cloud. If we look further into the edge architecture on the main Valkyrie skid, this is running a high performance Intel x86 processor. This is hosting the Ignition gateway that communicates over MQTT to the Ignition server in the cloud. It also has an SQL database, and then Streamline Innovations developed their own advanced control and analytics algorithms, and they run those in Python on Moxa Debian Linux. This edge gateway then connects to the traditional motors, PLCs, and gas analyzers using these types of process applications.
So if we sum up these two architectures, we're seeing edge gateways simply passing data through the cloud and edge gateways running full ignition alongside other advanced software that also communicates to an Azure cloud hosted ignition. Quite the range. And I think it's time for a poll to see where our attendees fall in this spectrum between these two sort of extremes. How are you using or intending to use the cloud in your application? Let's fire up that poll. How are you using the cloud? Are you simply transmitting data through the cloud to local servers? Are you using a cloud provider like AWS or Azure to store or serve your data? Are you running SCADA or Ignition in the cloud, or are you not using the cloud at all? And I suspect, again, that fourth answer, we probably won't see anyone choosing that. I'd be really shocked if we see anyone saying we're not using the cloud at all, considering, again, this is an IoT webinar. Let's give everyone a little bit more time.
It's okay if you're not. We still want to hear from you.
Yes, yes, yes. All right. Let's see if we get a healthy number of responses here. Very curious. Wow, we did get people who are not using the cloud. That is very interesting. One thing I will also note, we are starting to see some questions in the question and answer. So please keep using the Q&A to send your questions. We'll address as many as we can at the end. So I do see a couple that have already come in. But Robert, any thoughts on these answers here?
I think a lot of our customers are able to use some of the modern benefits of MQTT, but still have local servers. And so that's an application scenario that we're seeing as well. That's kind of a balance of the two trends. And so it'd be interesting to learn more from some of these customers where they kind of long-term see the data going.
All right, fair enough. So for this last section, I'm personally excited about presenting this because it addresses a common question that can be surprisingly difficult to answer. What combination of hardware and software will I need to support my IIoT deployment? Robert, why do you think it's taken so long to be able to provide a straight answer to this?
Well, to be fair, it took so long because we really needed to get to actual deployments and real test cases to test the scalability. And luckily, over the last 4 or 5 years, we've been able to reach that point. And so now to help you better select and size your application, we have collaborated with Inductive Automation to share even more specific benchmarks that you can use when selecting your edge architecture. Of course, our team here at Moxa is ready to help consult on the right hardware options, but now we can offer a more benchmark-driven approach to this process. But first, to provide some context, these benchmarks are based on key parameters, including number of device connections, number of tags, and number of visualization clients. While these are key benchmark indicators, there are many other factors that might impact actual performance. So a few examples of those include types of PLCs, SQL database throughput, network latency, and additional scripting or analytics that might be performed on the system. However, with that said, we think these 3 core indicators really do provide a good baseline to start for your hardware and software selection. And so now we're excited to share that these new benchmarks that we have available. Okay, so again, the key factors to consider are highlighted here in yellow: the number of device connections, the number of tags, and the visualization clients. Then the benchmarks are divided into 3 categories or 3 project types: a small ignition project, a medium ignition project, and a large one to keep it simple. So let's just start on the first row. Here for a small ignition project with less than 500 tags and up to 2 device connections, an ARM-based industrial IoT edge gateway can provide the right performance and an attractive price point. However, for certain applications that require more than 2 device connections, around 2,500 tags, or that need to add visualization, the added memory and performance of an x86 is really something you should consider. And really here, memory is a real important consideration. As you can see, as we move into the medium ignition project, here you can see as you increase the number of tags or the number of visualization clients, the memory is a big factor. In fact, for a medium-sized project, the first one, you'll want to consider between 4 gigs and then the largest medium-sized project up to 16 gigs of memory, a big difference indeed. And so we need to invest some time up front to determine the number of tags and the number of device connections needed as you scale, not just when you begin, but as you scale, because that memory needs to be built into the hardware when you order it. This is great news though. Using these benchmarks, you can better match your application to the suggested memory needed. Of course, if you're performing additional calculations, running an SQL database, or have a higher polling rate than once per second, You need to size the hardware larger than what these benchmarks show. But this is a great way to start. In addition to these benchmarks, we wanted to provide some initial advice on the right ignition software to run on our hardware. We see customers commonly evaluating a few options: Ignition Edge with panel, and Ignition Server. Based on the table here, starting from the far right, we recommend an Ignition Edge for applications that do not require visualization and have under 2 device connections, for example, connecting to 2 PLCs. If you need to add visualization, it's easy to upgrade and include Ignition Edge with panel. This gives you 2 visualization clients. However, like we saw with the Streamline Innovations case study, if you need to add local historians or visualization in the cloud and for operators at the edge, Ignition Server is likely the best fit. Now, to be fair, this is Mox's experience as we've supported our hardware, but Inductive Automation has a wide range of software beyond what we just covered. So we also recommend working with one of their system integrators, many of whom are also Moxa distributors, to help you design the right overall architecture. Oliver is now going to share some more specifics around Moxa hardware.
All right, I'll try to make this quick because I know we're already at the 10-minute mark. We want to start taking Q&A. But as Robert mentioned, quite a few customers are simply using Ignition Edge to bring tags from up to 2 remote PLCs via MQTT or Spark-Plug-B into their central server. ARM gateways are a great choice for this, and you have several options depending on your specific communication requirements and number of tags. They're also nice because they tend to be energy efficient, which can be an important consideration for remote installations. For customers that need an edge gateway to also serve up some local HMI visualization clients or to pull a larger number of tags, the x86 class Atom-powered gateways have proven to be a great and reliable choice. You'll run Ignition Edge IIoT and or Ignition Edge panel in this scenario. And for those that need even more power at the edge, our quad-core i7 edge gateways are a great option since it is one of the most powerful and most compact DIN rail industrial computers available today. This is what Streamline Innovations is using to run full Ignition Server as well as those advanced control and analytics algorithms. Try to keep it as simple as possible, but there may be, of course, additional nuance to consider for your specific needs. So hopefully you find this chart a useful starting point, and Moxa and Inductive can certainly work with you to determine the best fit for your specific needs. So with all that said, let's end with a poll question to see how well our findings align with your requirements. Which of the following most closely describes your edge requirements? No more than 2,000 tags and 2 devices, at least 500 tags and 1 or 2 local HMI visualization clients, 3 or more devices plus 3 or more HMI visualization clients, additional machine learning or other software alongside Ignition Edge, or finally the catch-all is way more complicated than any of the above. And again, this is an oversimplification, but this tends to sort of bucket the type of applications that we've seen over the past couple of years. All right, let's give you guys a few more seconds and then take a look at the results, then we can get to some Q&A. I'm very curious. The suspense is killing me. Let's take a look. Wow, it's a pretty
evenly distributed. Wow. Except for machine learning. We don't see much machine learning either.
Right. Still pretty new, but and the slight edge goes to the 2,000 tags and 2 devices. Any thoughts, Robert, on the this final poll result here?
You know, the thing I've seen the most is even within a common customer, they'll have different applications. And so I imagine many customers might want to select multiple of these because they just have different architectures within the same facility or the same company.
That's a good point. Maybe for the next version of this webinar, we'll make this pick any of the above or multiple choice. I know that's an option with Zoom. But without further ado, let's go into the Q&A. I've seen a couple of questions come in through the Q&A section. Robert, let me read out the question. Does Ignition Edge have store and forward capabilities? What happens in the event of cellular failure?
So yes, Ignition Edge has store and forward capabilities. And then if you notice on that chart, and afterwards you could look back, Ignition Edge also stores that data for a week. If you need additional data, it's basically where you get into the historian type of application. So you need to think about if you need that data stored locally beyond a week. Of course, you need enough memory locally to store it for that amount of time. So it's good to work with our field application engineers and calculate how much data storage you might need for how long in order to make sure you have enough extra memory for that application.
All right. Thank
Store
you.
and forward's a really popular feature, though, so great question.
Yes. This one isn't exactly a question, it's more of a comment, but I'll go ahead and read it and let you comment on it or respond to it. My impression is that most or all of these use cases and examples are process focused and that the new IIoT paradigm is lagging in discrete manufacturing. Care to comment, Robert?
Yeah, I actually opened the webinar with essentially a similar statement. Those three categories that we see, the first, edge to cloud, edge to modern SCADA. We are seeing a lot more of that in process, in distributed and remote applications, what we used to call machine to machine. And you're correct. In traditional factory automation applications, we see a lot of interest, but actual deployments, there's not as many. I think that does make sense. The number of devices, the amount of hardware installed that can be 5, 10, 15, 20 years old is just much larger there. And so transitions take more time. The great news is Moxa supports all of those applications, but for IoT, I agree with the attendees' observations as well.
All right. Thank you, Robert. Here's a question that probably will have to punt, but I'll go ahead and read it out loud since there seems to be interest. What is the price range for the quad core gateway, and is it class 1 div 2?
Well, Oliver, you're the best at specifics. I'm not supposed to get into pricing. So maybe you take half that question. I know that half of it's an easy one.
Yes. And we do have class 1 div 2 options of pretty much all of the hardware that we presented in terms of hardware recommendations. Oil and gas has been one of the early adopters that we've seen for IoT, that and also renewable energy, interestingly enough. And as for the price range, we'll have to get back to you. Please feel free to reach out to us directly after the webinar, or we can contact you and sort of get a quote going out to you. All right, next question, a few more questions before we close out the webinar. Does Ignition Edge IIoT support raw MQTT?
I want to be very precise here. It supports MQTT. Raw MQTT, I'm not sure is anything different, but yes, it's MQTT, and then you could also run Sparkplug on top of that. So I think the answer is yes. The raw MQTT might need further clarification.
Wonderful. More questions are rolling in, so I'll try to get to as many of them as I can. What solution would be recommended for dozens of sites reporting to a central server, each site less than 100 tags, and central server stores the data forever? Some sites do not allow internet, so it would have to be submitted to the server manually. Data is used for visual reporting of the processes. This is a pretty detailed question. Sounds like an online consulting, but Robert, care to comment at a high level?
Well, that would actually be my first comment, is I recommend those type of detailed architectural discussions for us to engage in and to get our field application engineers and our teams involved. Generally, when I get engaged in those, we ask as many questions to begin with as we provide. But based on what you said, Oliver, a few high-level takeaways. One, that architecture with a control center, with a centralized Ignition server storing the data in a historian seems to make sense. And two, I'd start asking questions about how to overcome that manual transfer of data. Perhaps a private cellular network could enable you to get that data to the centralized server without having to transfer it manually. Anyway, there's more questions to ask in part of the architectural discussion.
Really is a consultative sort of discussion that's required, but the great questions. Here's one that's hopefully pretty quick. Can Ignition Edge MQTT be used for bi-directional communication, PLC to SCADA and SCADA to PLC tag updated?
Yes, you just have to make sure the PLC speaks those languages, or there's a gateway there that can translate. And specifically it speaks MQTT.
All right. There is another rather detailed question on an application. I'll just read it. I don't know if I'll even have time to finish it, but we are using perspective to run many. You know what? We don't have time to even go through that. It's like a paragraph of a question. But for those of you that we weren't able to answer the questions directly online, please feel free to reach out to us directly via LinkedIn, by email. We'll be also sending an email that has, I believe, the recording of the webinar, and you can respond to that if you want us to follow up or to have a discussion about your specific application.
And Oliver, I might just say for those two questions I heard, and for any others who have questions like that, that's exactly what our team does. We have field application engineers. I myself am willing to get involved, and we have a dedicated team of sales who can get on a phone call with you and really walk through your architecture and give you some recommendations, and even bring in a system integrator or help you if you want to do the application yourself. So we field those questions in depth all the time, and we've actually gained a lot of experience doing it. Please reach out. That's the best way to handle those. I can't do it justice in the time given.
Wonderful. Well, thank you very much, Robert, for your time, and thank you everyone who gave their time today to attend this webinar. We hope you found this useful. Everyone have a great rest of your day, and do reach out to us if you would like some of that consultative approach and discussion about your specific application. Thank you very much, guys. Have a good day.